Good afternoon, everyone.
Good afternoon.
Today I am critically evaluating a proposed reforestation model for the Amazon rainforest. While planting trees sounds inherently positive, we must examine whether basic replanting strategies can truly counteract the rapid velocity of modern tropical deforestation, or if they merely function as a superficial band aid on a systematic environmental crisis. To understand why we need a flawless restoration plan, we must look at the scale of the Amazon. It is not just a regional woodland, it spans 9 nations. It holds over a tenth of all known species on Earth and drives global weather patterns. Deforestation here doesn't just destroy local trees, it disrupts rainfall across global agricultural systems. The Amazon's biodiversity relies on a complex, multi-tiered canopy ecosystems. When we clear cut a section, we don't just remove wood, we destroy microclimates that specialized animals call home. Replanting a tree does not instantly bring back the complex web of insects, fungi, and predators that depended on the ancient tree that stood there before. The Amazon acts as a massive terrestrial carbon sink, locking away up to 200 billion tons of carbon. When burned or cleared, the carbon shifts directly into our atmosphere, accelerating global climate change. Recent data shows parts of the Amazon are now releasing more carbon than they absorb due to heavy deforestation pressures. This slide right here visualizes our baseline deforestation data over the 10-year timeline. We begin with a healthy, fully intact forest grid up here. By year 5, 6 blocks are completely leveled. And by year 10, an additional 11 blocks vanish, leaving less than a third of our original forest standing. This highlights the accelerating speed of land clearance. Here is the government's proposed restoration plan. In year 5, 3 blocks are replanted, which is shown up in the blue here. And year 10, 5 more blocks are replanted. And on paper, it looks like we recovered 8 blocks. However, a major issue remains. At the end of the 10 years, 9 blocks are still completely bare, and our restored blocks are not ecologically identical to the green blocks. Now let's critique the core plan. The clear strength is simplicity. Planting saplings is straightforward and helps anchor vulnerable topsoil. The glaring weakness here, scale. The plan replaces only a fraction of what is destroyed, leaving a net loss of the 9 blocks. It treats the symptom of forest loss without stopping the ongoing chainsaw clearing. Do new trees provide the same resources as adult trees? Absolutely not. A newly planted sapling cannot provide a canopy home for birds, large hollows for nesting mammals, or the massive fruit yields that sustain wildlife. It takes decades for a sapling to mature into a functional ecosystem anchor. For the local animals, a replanted block is still unlivable for a very long time. Our first alternative solution moves away from total clearing towards agroforestry. Instead of flattening blocks for open cattle ranching, farmers plant high-value crops like cacao or coffee directly beneath the canopy trees. This keeps the overarching forest structure intact, providing local communities with a sustainable economic income. Implementing agroforestry requires setting up regional native seed banks and training communities in complex multi-crop farming. The main benefit is that it keeps trees in the ground while supporting the local economy. The downside is the multi-year delay before farmers harvest their first profitable crops, requiring transitional financial aid. Alternative solution 2 tackles the root cause. Stopping illegal logging before it happens. By using real-time satellite imagery paired with predictive AI, we can automatically detect the moment a road is cleared or a tree falls, allowing rangers to intercept illegal operations instantly. The resources needed for this are highly technical. Long-range solar-powered drones, AI algorithms to identify machinery from space, and encrypted communications for field teams. This advantage is swift, proactive protection. The drawback is that significant upfront cost and the constant challenge of maintaining advanced hardware in these harsh jungle environments. My third alternative addresses international finance through debt for nature swaps. Under this mechanism, international creditors forgive portions of developing nations' foreign debt, and in return, the host country commits those exact same funds to long-term, strictly enforced forest conservation funds. This solution requires heavily on international legal frameworks and strict third-party verification to ensure the money actually goes towards conservation. The huge benefit is that it solves the underlying financial pressure that drives countries to log their forests. The challenge lies in navigating complex international treaties and ensuring local political stability. In conclusion, my critique level reveals that simply planting saplings will always lag behind the speed of chainsaws. To truly save the Amazon, you must pair reforestation with technological enforcement to protect old growth trees while offering economic alternatives like agroforestry and debt swaps. The holistic approach ensures the forest remains standing for generations to come. This concludes my presentation. The data, ecological insights, and alternative models presented here today are built entirely off of verified research from the International Conservation and Space Agencies. Thank you.